Hello students, today we are going to discuss about a very important method, that is Newton-Raphson method. So this is the formula of Newton-Raphson method and it's very easy to remember. It is also known as Newton's iteration formula. So this can be asked in MCQ. Also remember that Newton-Raphson method has quadratic convergence and the convergence is of the order 2. So this can also be asked in MCQ. Okay, so let us consider an example to understand the concept thoroughly. So this is the example. So the function is 3x minus cos x minus 1. So आपको क्या करना है, जो भी चीज़ें हैं वो एक साइड पे ले लेना है. Fine. Then you are supposed to solve. Then we need to find its derivative. So it will be nothing but 3 plus sin x होता है derivative cos x का, and derivative of constant is 0. So this will be the derivative. Now we need to find the value of function at 0, and it will be 3 multiplied by 0 minus cos value at 0 plus 1. That will be nothing but, yes, it will be minus 2. Next we need to find the value of the function at 1. So it will be 3 multiplied by 1 minus cos value at 1 plus 1. So that will be nothing but 1.4597. Okay. Now you need to remember some important concept, that is note. Fix your calculator in radian, because you can see that we are having a cos function in the equation, and equation is a transcendental equation also. So this is very important. Now let us come to the next important concept, that is to find the interval. Now the function value at 0 is negative 2, which is negative value, and function value at 1 is positive, that is 1.4597. So f of a into f of b is negative. This implies we will have a root in the interval 0, 1. Fine. So we have got an assurance that we will have a root in the interval 0, 1. Now we need to choose one value at x naught. So it can be 0 or it can be 1 or it can be any mid value from the interval. So we are taking the value of x naught as 1. So at my choice, you can take it as 0 or you can take it as 0.5 also. Now let us prepare the table. So this will be n, this is my x naught, this will be my function value at x naught, this will be the function derivative value at x naught, and it will be, I'm making the table easy, so it will be function value x naught divided by the derivative value at that particular x naught, and this will be my x1 that I will be getting as an output. So n will be 1, x naught we have chosen is 1, and the function value we have already calculated, it is nothing but 1.4597. Now let us calculate the derivative value at 1. So it was from 3 plus sin x. Okay, so if you put it over there, you will get 3.8415. Now what we will be doing, we will be dividing these two terms, values. So it will be nothing but, let us calculate it. So it is coming out to be 0.3799. So for x1, what you are supposed to do, take the difference of this value, that is 0.3799 from 1. So it will be nothing but 0.620. Now let us go with the second iteration. So it will be 2, and you need to use this value as your x naught. So it will be 0.620. Again find the value of function at 0.620. So it is coming out to be 0.0461. 1. Correct? Okay. Now find the value of the derivative that we have got at 0.620, and it is coming out to be 3.580. Now again divide these two values, so that will give you nothing but 0.0128. Correct? Now take the difference of this value from the value that is 0.620, and it will be nothing but 0.6071. Now let us move to the next value of n as 3. So take the value of 0.607 as over here. So this will be 0.6071. Find the value of function at this point. So it is coming out to be, yes, it will be minus 5.88 into 10 to the power minus 6. Now find the value of the derivative, that is 3 plus sin x, at 0.6071. So it is 3.5705. Now again divide these two values, and it will be nothing but negative 1.64 into 10 to the power minus 6. Okay, now we need to divide this, we need to take a difference of this particular value from 0.6071, and it will be nothing but 0.6071. You can note that this value is nothing but 0.00000164, and it's approximately equals to 0 only. So this implies x equals to 0.6071 is the approximate root. Correct? So let us note it down. x0 is, this is the approximate root. Now I have done some research for you so that you don't commit mistake in your exam. So what I have done, I have solved it from online site, and it is the value that I am getting if I start the things from 1. So I prepared this particular from an online site, and they are also using some different table. Fine, but the solution is the same that we have got. Now this is when I am starting the things from 0, because I have said that if you want to start, you can start from 0 also. So you can also see that we are also getting the same value, that is 0.6071. So you're not getting different value. And if you start from 0.5, so again you're getting the same value. Correct? So it is the thing that if you want to start from this particular value also, then you can. Correct? So it's up to you. Okay, so in all the three we are getting the same answer. So let us note it down. Fine. So in all the three cases we are getting the same solution. Okay, so let us decide that generally we will start from the value that is 0.5, that is the mid value of the interval. Okay, because generally what happens that you need to decide, it might be possible that the root is somewhere far from the one end, so it will be easy that we start the things from the midpoint. Okay, that's why we are deciding that we will start from the mid value, that is 0.5. You can also see the number of iteration that we are getting for the 0 value. Okay, thank you so much. I hope that you are clear with the concept.